Hi, I'm Wade from Confluent. I've been trying out Apache Flink for the past few months, with some help from some of the top experts in the field. In a perfect world, everyone would have high-quality experts in their pockets that could be pulled out whenever necessary. Although, I guess if you're watching this on your phone, then you kind of do have experts in your pocket. So with that in mind, I'd like to pass along some of the expertise I benefited from while learning Flink. I'm going to show you how to build a Flink job that produces data to a Kafka topic. The job I'm building will create records for a fictional airline known as Sky-One Airlines. The data it produces will feed other downstream Flink jobs. However, since this airline is fictional, I don't have any real data to work with. Instead, I have to randomly generate some. I'll make use of some Flink features to create a stream of random events and then push them into a Kafka topic. Any bets on whether my flights end up on time more often than the real ones? With this basic outline in mind, let's write some code. The Flink job is going to be generating data, so I'm going to drop it into a package named DataGen. Of course, I will have a bunch of imports at the top of the file, but we'll just skip past those. Feel free to pause the video if you want to see them in more detail. Now, we need a class to contain our logic, so I'll create one and name it DataGeneratorJob. The entry point for the job is a Java main method which accepts an array of arguments. And I'll just throw all exceptions because I'm lazy. In a production application, I might implement better error handling, although I do appreciate the let it crash mentality, which allows for applications to shut down and restart when they encounter an error. As it happens, this is something that Flink supports quite well, so it may not be necessary to implement better error handling, as long as I allow Flink to restart the application if it fails. Flink data streaming jobs generally start with a stream execution environment. Let's create that and name it env. We can use the streamExecutionEnvironment.getExecutionEnvironment method to populate it. We need access to some Kafka configurations like the bootstrap servers and credentials. These can be loaded into a Java properties object. We create an input stream and use the class loader to read a producer.properties file into the properties object. That takes care of the boilerplate. Now let's do something more interesting. Every Flink stream needs a data source. A stream processing framework that doesn't have any data would be pretty boring. Although it would be a lot easier to implement because at that point you kind of don't need any code at all. The data in this job will be randomly generated. I'll use a data generator source that produces Sky-One Airlines flight data. It will be named Sky-One Source. To create the data generator, we need to pass a function that takes an index parameter and produces an object. We will be producing a new Sky-One Airlines data object for each index, but the value of the index doesn't actually matter. We also need to specify how many objects to produce. Using long max value will ensure that this stream runs for as long as necessary. Producing the data as fast as possible isn't very realistic for this use case. It also would be quite dangerous to leave running while it's connected to my Confluent cloud account. I would absolutely forget to turn this off and come back after a weekend to a ridiculous cloud bill. So let's not do that. Instead, introducing a rate limiter strategy allows us to ensure that only one record is produced per second. That's a little more reasonable and much more affordable. The final thing we need is some type information for the Sky-One Airlines flight data class. Incidentally, data generator sources can be quite useful for writing tests in Flink, so it's a nice tool to have in your pocket. Once we have a data source, we need to turn it into a data stream. We'll call this Sky-One Stream and create it using the FromSource method. We need to include a watermark strategy and a name for the source. This gives us a stream we can consume. The next thing is to create a data sink. The sink acts as a destination for the data. In this case, we'll be creating a sink to a Kafka topic. To create a sink, we need to provide Flink with some details about how to serialize each record. This requires a Kafka serialization schema for the data type we will be using, in this case, Sky-1 Airlines flight data. We can use the Kafka record serialization schema builder to create our schema. The builder requires a topic that tells Kafka where these records will be published. It also requires some details about how to serialize each record. In this case, the records are going to be stored in the value portion of the Kafka message, so we will use a value serialization schema. We could also introduce a key serialization schema if it was required, but in this case it's unnecessary. We're going to serialize using JSON, so we make use of a JSON serialization schema. This tells Flink to use the built-in Jackson JSON serializer. However, the Sky-1 Airlines flight data object contains dates stored as zoned date time objects. By default, Jackson doesn't know how to serialize these. If we try, it will throw an exception. We can resolve this by registering the Java time module with the object mapper. Notice how the object mapper is provided using a Lambda function. This is done because many of the components we create need to be serialized as Flink distributes the job across a cluster, including the serializer. However, the Java time module is not serializable because, well, reasons? Rather than trying to use a non-serializable instance of the object, which would fail, we instead serialize a function that will create the object when necessary. Working with Flink, you will often find places where you need to worry about these types of serialization problems. For more details about Flink's internal serialization, you can check out the course Building Flink Applications with Java on Confluent Developer. The final step for our serializer is to build it. Now that we know how to serialize each record, we can work on the connection to Kafka. Let's create a Kafka Sink for Sky-1 Airlines flight data and call it Sky-1 Sink. The sink requires a Kafka producer config, which we have already created, so we'll pass that here. It also requires a record serializer, so again, let's give it one. Finally, we're going to need to set a delivery guarantee. In this case, we'll use at least once. Flink also supports an exactly once delivery guarantee, however, it requires just a little more effort. To use it, we would have to enable checkpointing, which would then require me to explain checkpointing, and that's much too large a topic for today's video. If you do want to learn about checkpointing, check out the Flink 101 course on Confluent Developer. Anyway, let's build the sink. With all of the pieces in place, we can wire together our job. We start with our Sky-1 stream of randomly generated records. We use the sync2 method to push those records into our Sky-1 sink. As a good practice, we should also name the stream because it will make it easier to understand when we look at it in the Flink dashboard. And finally, we are ready to execute the job, giving it a name, in this case, input streams. Once our code is written, we can go ahead and execute it. We start by using Maven to build the jar file by executing maven clean package. Eventually, this should succeed. We can run the job using the Flink run command and passing the -c argument to specify an entry point, assuming we didn't register the entry point in the jar manifest file. And now we can take a look at the results. Let's start in the Flink dashboard by navigating to the specific job. There's actually not much to see here. If we look at the running task, we'll see fields like bytes and records sent or received, but they all say 0. Does this mean the job isn't working? Fortunately, or maybe unfortunately, it doesn't. These fields aren't used to track data entering or leaving Flink. They are used when data is being passed internally between tasks in a Flink job. In our case, everything is running as a single task, so there's no data being passed internally. As a result, these values show up as 0 and don't give us any insight into what the job is doing. We could check the logs, but we didn't set up the application to log anything, so they're pretty boring as well. If we want to see if the job is working, we're going to have to go all the way to Kafka. If I open up my topic in Confluent Cloud and navigate to the Messages tab, I will be able to see what messages are being created. You can see as my application continues to run, it periodically pushes messages into Kafka. We can expand those messages to get a better look at the actual JSON being produced. And here it looks like everything is working properly, including the dates where we had to take a few extra steps. So there we go. We have successfully created a Flink job that will randomly generate airline data and push it into a Kafka topic where it can be consumed by other systems, perhaps even other Flink jobs. If you want more information on Flink or want to try this yourself, check out the course Building Flink Applications in Java on Confluent Developer. Feel free to drop a comment below and let us know what topic you'd like us to explore next. Don't forget to like, share, and subscribe for more awesome content. And thanks for watching.